Hey everyone, welcome back to part 4 of our Python RegEx series. If you have been following along, we have already tackled regex functions like re.search and re.findAll, meta characters like asterisk, plus, and question mark, and character classes like \w for word characters and custom ABC sets with square brackets. Today we are diving into some seriously powerful regex concepts. Boundaries, groups, lookaheads, lookbehinds, and greedy versus lazy matching. These tools let us control exactly where and how our patterns match, and even capture specific pieces of text for later use. We will go deep into each topic with practical examples. If you are ready, let's get started. So, our first topic is boundaries, which controls where matches happen. In regex, boundaries define where a pattern should match in a string, making our search super precise. We have already seen caret, which matches the start of a line, and dollar, which matches the end of a line. These are classical that match full strings. But here's another useful thing, which is written as \b marks a word boundary like the start or end of a word, typically where a word character, like a letter, meets a non-word character like a space or punctuation. Opposite of it, uppercase B marks a non-word boundary, meaning inside a word where word characters are adjacent. Why are boundaries important? Imagine you want to find the word cat, but not when it's part of category or catastrophe. If you search the text here with the pattern above, it will only match cat but not category because we predefined a boundary around, so without boundaries regex can't tell the difference. If you use this pattern for the sentence given, it will only match cat but not category because the \b ensures there is a boundary like a space or the start of the string before and after cat. Let's see that in a code example. Here in our code example, we have a sample text as I have a cat and a category, and we will try to find only word cat in this text. So let's define our pattern equals a row string as lowercase b cat lowercase b. So we define a boundary here, and after that, let's type match equals re dot find all pattern text. You can also define pattern here, but I used a variable to make it clear. So if you print match, as you can see, it prints cat here. If you do something like this, use uppercase b opposite of this, it will match nothing. The lowercase b was used for exact work. Now, if you want to use uppercase b, the word cat must be inside another word. So let's make it scattered, and if you run it, you can see it finds cat here. So if you search it inside a word, you can use uppercase B or make it super category in example. It's meaningless, but you can see it finds two cats. You can also use lowercase b or uppercase b on just one side of a pattern in regular expression. So if you use it in example, modify this string and type lowercase b, and if you run it, it matches two cats again. But how? Because it matches cat when it starts a word. First, it matches the standalone cat, then it matches cat in category because it's at the start of the word preceded by a space. If you move this b to end of the cat, it only matches the standalone cat because it's followed by a space, a word boundary, so it matches cat when it ends a word only. Uppercase B is opposite, so if you type \uppercase B cat and you run it, it's empty because the pattern \uppercase B cat requires the position before cat to be a non-word boundary in this text. The first one, the standalone cat, is preceded by a space, and the second one, cat in category, is preceded by a space. Let's type I have a cat and a bobcat. So if you print it, two matches here found. Let's move this uppercase B to end and run it again. It matches nothing, as you can see. But if you type I have cats and bobcats, both cat words because it's followed by a word character. But it does not match standalone cat, so it's useful for finding cat as a prefix or within a word. Now, next up is groups. Groups let you capture specific parts of a match using parentheses. This is super useful when you want to extract pieces of a pattern like parts of a phone number or email. You can access groups with match.group1, match.group2, etc. In the given example, we have three different groups in our pattern, as you can see, with three distinct parentheses. Inside this parentheses, the first two groups have 3 digits and the last group has 4 digits. It will yield a result like 1, 2, 3 is one group, 4, 5, 6 is another group, and 7, 8, 9, 0 is another group. And the whole pattern is group 0, so you can access them using the 0. You can also name these groups using question mark P inside parentheses type group name, which we will see in code, and you can refer to it in example like area, prefix, and line by name. Let's code and see it. So everyone, our sample text is AUS phone number. Now we will extract distinct groups from it. So let's use named groups too. Pattern equals R, a row string again, parentheses, so we will define a group inside it, question mark P type area followed by backslash D, so 3 digits. After that, it's followed by a hyphen because its format is like that. Again, another group named prefix backslash D 3 and another hyphen P line with 4 digits now. Now you should use an RE model function that returns a match object. If you remember, find all returns a list, so you can use in example re.search. So match equals re.search. If you missed it, you can refer to our previous videos about RegEx. Pattern text. So now you should check if it's none or it matched exactly with the pattern. So you remember from previous tutorials, you use if match, print match dot group area, print match dot group prefix, print match dot group line. So let's run it. It must be an uppercase here. Let's run it. It's 1, 2, 3, 4, 5, 6, and 7, 8, 9, 0. You can also use numbers, let's say 0, 1, 2, and 3. Match.group 0 is the whole pattern you extract from this text. Group 1 is the first group, group 2 is the second group, and group 3 is the third group you defined. Groups are like slicing up your match into usable pieces, so it's perfect for extracting data like splitting an email into username and domain, which we will do later. Now let's talk about lookaheads and lookbehinds. First, let's see why lookaheads are used. Lookaheads let you check what comes after your pattern without including it in the match. There are two types. First one is positive lookahead. The first expression here, foo inside parentheses question mark equals bar, matches foo only when followed by bar. The negative version, which strike through here, matches foo only when it's not followed by bar. Second one is look behind. Its syntax is given here inside parentheses question mark greater than or equal to foo followed by bar, so it matches bar only when preceded by foo. Negative version of it matches bar only when it's not preceded by foo. So negative versions of look ahead and look behind is opposite of their positive versions. Here we have a sample text that includes domain names with .com. Let's find the domains followed by .com. So we will filter only the domains include .com, not .org. So we can use a pattern like this. Pattern equals row string that includes one or more occurrences of word characters, so it might include digit, letter, etc., followed by a look ahead, followed by, it's question mark, followed by equals backslash dot com. Why backslash dot? Because if you remember, is a meta character, so you need to escape it using backslash. So here we mean dot character, not the meta character dot. Be careful here. And com is the sequence we want, so we type it directly. So one or more occurrences of word characters followed by .com. After that, can find match equals re.findAll. Can use find all here. We do not use grouping here. Pattern text and print match. You can see it matches example.com and another.com, but without com, so you don't need to search for com, but it finds once which is followed by .com. You want to use negative version of it, you can just use the exclamation mark, so it will find everything that is not followed by .com. Example without E is followed by E.com, so it's not .com. Com is not followed by .com. Test is not followed by .com, etc. So negative version is useful in some cases. So everyone, let's work on Lookbehinds. Here we have a sample text again, and let's craft our pattern. So pattern, let's find the ones preceded by at equals row string question mark less than or equal to at and close it backslash w plus. So you look for at symbols before and followed by one or more occurrences of word characters. But be careful, in Python, Lookbehinds must have a fixed length. So this one works, but something with quantifiers like plus, asterisk, or another thing won't work. This is a Python query, but is manageable for most cases, like parsing emails or logs. So be careful here. You can use them after the look behind. And let's match equals re.findAll pattern text and print match. So it matches with example and domain. If you use negative version, so instead of equals, we use exclamation mark, it matches everything that not preceded by at symbol. Now let's dive deep into greedy versus lazy matching. This is all about how much a regex pattern matches when using quantifiers like asterisk 0 or more, plus 1 or more, or curly braces, in example between n and m times. By default, regex is greedy, it matches as much as possible. Adding a question mark after the quantifier makes it lazy, it matches as little as possible. So greedy is used when you want the longest possible match, like capturing entire sections, and lazy matching use it for precise minimal matches like parsing tags or delimited text. In example, dot followed by asterisk followed by question mark is used for lazy matching, whereas dot asterisk is greedy. In addition, plus and between n and m are also greedy by default. Greedy matching can overreach, grabbing more text than you want, especially in structured data like HTML, XML, or logs. Lazy matching lets you fine-tune your matches for precision. Let's break it down with detailed examples to see difference. So everyone, let's assume that you have an HTML code. Here is a web page code. You want to parse and extract meaningful parts. In example, you want to extract paragraphs and you want to first try greedy. Let's try it. So everyone, let's define pattern greedy. Pattern greedy equals a row string starts by p tag. If you remember, dot and asterisk is greedy, followed by a closing tag. So let's print re.findAll pattern greedy inside text. Let's run it. As you can see, It matches the long sequence here in the text. It starts by this P ends here. Let's also try pattern lazy. So pattern lazy equals, you just add a question mark after dot asterisk, so row string P dot asterisk question mark close P and print re dot find all pattern lazy in text. Now it matches both paragraphs, so you can extract them separately. One is hello, other one is word. So another thing I want to mention is alternation. It helps you to alternate between patterns. In example, let's find cat or dog in the sample text. So let's type pattern equals row string cat type dog and print re dot find all pattern in text match with cat and dog. You can also use groups here. If you remember, let's type it p animal. And if you use something like search, so let's type match equals re dot search pattern text print match dot group animal. It matches cat. So if you want to still use match object and also include the dog, you can use find either. So let's type find either instead of search and type for match in match print not match. Now it's match dot group animal, both cat and dog here. If you use find all, it will return a list instead, but if you do not want to lose groups, you can use re.findEther, so you can employ full functionality. So everyone, thanks for watching this deep dive into regular expressions and how they can supercharge your coding projects. If you found this video helpful, do not forget to give it a thumbs up and subscribe to the channel for supporting us. In the next video, we will see more examples related with real life and we will learn how to use regex in real world problems. See you later.